Okay, what if instead we are wanting to know what is the distance between the first bright spot and the second bright spot? Now, how would that change what we're doing here? Well, if you look at the second bright spot that forms, you know the second bright spot is a result of the waves from the center point and the waves from this point being in phase with one another. So, you know, so we take, if we were to draw this triangle out one more time, we would ask ourselves, what is the difference in path length for this spot right here? Well, they're combining together, so the difference in path must be equal to, here the difference in path is nothing, right? From here to here, or is there something? Are they going the same distance? No, they're not. This is probably a difference in path of, it's going to be an integer number of wavelengths, so it's either 1 lambda or 2 lambda up here. But I'm curious about this point right here. Are they in phase because the path length is 1 lambda difference? I think so. From here to here and here to here. So what about the next dark spot? So we have a dark spot right here. Let's see, here's our dark spot. I'm going to just make it blue. First dark spot, we know that the path difference from the waves that are traveling from this point and the waves that are traveling from this point, the path difference is lambda over 2. But what about the next dark spot? So if we were now to draw a line, and this is going to get really messy, so I'm going to start here first to draw a line from here going up here, and by the way, this is all not to scale, completely distorted, and from here to here, and the difference in path lengths that we would compute would have to be something from, you know, dropping the perpendiculars over here. That's a bad color. I'm going to use a red-ish something. So here, the new one. So the difference in path for these guys is somewhere in here. We use the same equation, and we come up with that the difference in path must be equal to, well, this was lambda over 2. They're totally out of phase here. So it must be 1 plus 1.5 lambda. Again, out of phase, but shifted by a wavelength. So this is equal to 3/2 times lambda is the difference in path length for this next spot right here. Again, the geometry is the same. We've got that angle theta, or theta prime now, and we can figure out this distance between this guy and this guy, or even from the center point and the second dark spot.